Welcome back to our Specialist Mathematics series. Today we're doing Argand diagrams. Let's get straight into it. So an Argand diagram is a geometric representation of complex numbers. So if you say plotted -1 plus 2i, we can plot that on an Argand diagram. So as we can see here, the y-axis is the imaginary component of z, and the x-axis is the real component of z. As we have learned, this is the real component and this is the imaginary component. Therefore, -1 and 2 up. Every sort of complex number with the operations of addition, subtraction, multiplication by like a real constant all have like geometric interpretations, and they're basically coordinates on an Argand diagram. Multiplication by complex number I, so say if you have like -1 plus 2i and you times it by I, it basically shifts it like 90 degrees. Pretty simple. And complex conjugate corresponds to the reflection in the horizontal axis. So basically, a conjugate is where you multiply it by the denominator, where you multiply the conjugate. You know, we've learnt conjugates before. It basically reflects it about the x-axis. Let's do it. Let's get straight into it. Question 1. Write down the complex numbers represented on this Argand diagram. So, A, B, C, D, E, and F. For A, let's look at A. The real component is 3, and the imaginary component is 1, plus I. Now we look at B. The real component is 0, and the imaginary component is 2, so it's just 2i. For C, over here, it corresponds with -3 for the real component, so -3 minus 4i, and it corresponds with -4 on the imaginary axis. D corresponds with 2 and -2, so it's 2 minus 2i. E here, it has no imaginary component, it's just -3. And F, -1 minus I. Pretty simple, right? Represent each of the following complex numbers as points on an Argand diagram. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3. Okay. 3, we move 3 units to the right. Minus 4, we'll call that 4. 3 units to the right. Minus 4. We draw a line, a straight line. And we call that A. B. -4 units in the about the real axis. -4 plus 1 plus I. So it's here. And we call this B. C. 4 plus I. Now 4 units in the positive direction plus 1. As you can see, that's a reflection. So because this changed from a negative to a positive, it's just reflected about the y-axis, as you can see there. D is -3. It doesn't have an imaginary component, so it's just here. We call that D. You kind of don't really need to label it because it's already on the axis. E, -2i. That doesn't have a real component, so it's just here. E here. And F, -5 minus 2i. negative 5 units in the real direction and negative 2 units in the imaginary axis. So that ends up there. F. Pretty simple. Now we're going to have to do some complex numbers, addition and subtraction, sorry. Like multiplication comes later. Now, if Z1 equals 6 minus 5i and Z2 equals negative 3 plus 4i, Z1 plus Z2, now let's deal with the real components, equals 6 minus 3 equals 3 plus negative 5 plus 4. 3 plus negative 1, or so 3 minus I. A equals 3 minus I. Now we go 3 units in the positive direction and minus 1 in the about the imaginary direction. That's A. Now for B equals 2 6 minus negative 3 plus negative 5 minus 4 equals to 9 plus negative 9, so minus 9i. So 9 in this direction and negative 9 in this direction. We can call this B. There we go. Simple. Question 4. If Z equals 1 plus 3i, represent it on the following Argand diagram. Now, 1 plus 3i, I'm sure we all know that by now, 1 unit in the real direction, plus 3. We can call this A. Well, we can just call that Z, because that's just Z. Okay, now that we've done A, we need to do B. Now Z and Z bar are different things. Now if, we can use this rule here, if Z equals to, what was the rule again? That's right, plus yi, Z bar is equal to x minus yi. Therefore, if we put the same equation onto here, Z bar is equal to 1 minus 3i, which is just here. Modulus, not the modulus, conjugate. This is what's called the conjugate. Now, Z squared is equal to 1 plus 3i, 1 plus 3i. Okay, now we need to expand the brackets. So 1 times 1 is 1, plus 1 times 3i, which is 3i, plus 1 times 3i, which is 3i. And then 3i times 3i is 9i squared, equals to 1 plus 6i plus 9i squared. Now what is I squared? Negative 1, equals to 1 plus 6i minus 9, equals to negative 8 plus 6i. This is 8 plus 6i. So out here somewhere. It's not really to scale, so it doesn't really matter, but we'll just try and be Z squared. Negative Z, it's pretty self-explanatory, equals to negative 1 plus 3i equals negative 1 minus 3i. Negative 1 minus 3i, so it's this, negative z. As you can see, we're kind of making our way around here. And 1 over z, so 1 over 1 plus 3i. Now we need to times both top and bottom by 1 plus 3i plus 3i. Now this equals 1 plus 3i over what we had before, which was negative 8 plus 6i. Oh, right. What am I doing? Multiply by the conjugate. Man. 1 minus 3i. I just forgot about that. How did I forget about that? Let's multiply by the conjugate. 1 plus 3i times 1 minus 3i. Now if we do the same thing, 1 times 1 is 1, plus 3i, well, minus 3i, plus 3i, and then minus 9i squared. Those two cancel. That goes to negative 1. I squared goes to negative 1. Then we're left with 1 plus 9 equals 10. 1 plus 3i over 10. That's a very small thing here. So 1 plus 3i over 10, so 1/10 this way. So 1/10 this way. So 1/10 this way. Oh man. So 1/10 in this direction here, and 3/10 down, so like here, close to like here somewhere, over z. Yeah, you get the point. Well, oh, okay. Z times I. Now if we remember back to the rule here, you remember the rule here? A multiplication by a complex number by I corresponds to a rotation of 90 degrees clockwise about the origin. Which means we're just going to keep circling, essentially. This question is up to you. I'm going to leave you to it. Screenshot it. Say if you've done it in the comments below and I can help you out. See you later.